in order to rewrite the equation of this ellipse in standard form, which will then help us graph and identify the vertices and so on like we've been doing, I'm first going to want to use completing the square to do this. So let's take a look at how that's going to go. If you watched or in class our process on using completing the square to rewrite the equation of a circle, rewriting for an ellipse is going to be very, very similar with one little twist in it. So first part is the same though. Let's get all our x squared or our x terms grouped together and get all our y terms grouped together. So if I rewrite this, I'm going to have 25x squared plus 250x. I'm going to try to switch colors here to keep this a little organized. Let's go blue. Let's go with the y terms next, so plus 9y squared. And then minus 36y. And then finally, I'm going to take any constants we have and just move those to the other side. So equals negative 436. So same step we've done before. Next up then, and here's really the only, one of the two new steps of these problems. I'm going to want to, before I can do any of the magic number complete the square stuff, I need to factor out anything that's in front of the x or y squared terms. And to do this, I'm going to use our old friend, the greatest common factor. So looking at the two parts in green, I can see that both of those are divisible by 25. And if you have a good problem, then you should be able to factor this out relatively easily without having to work with any fractions. So if I take out a 25, I'd have x squared plus 10x. And then right away, I'm going to do the plus blank for that magic number stuff that's coming up here in a moment. So let's do the same now with the blue y parts. So looking at the two y terms, I can see that both of those are divisible by 9. So let's factor out a 9. What's left then is y squared minus 4y, and then once again I'll do the plus blank for the magic number that's coming up in a moment, okay? And then equals, let's see, negative 436, okay? Also, right away you may remember that I'm going to add those blanks to the other side as well, because we can't just add something to one side of an equation without adding it to both sides. So I'm going to have two blanks down for the two magic numbers, the x and the y, the blue and the green values. So let's go about how we would find those magic numbers. Quick refresher if you need to see that. So it's really the c value. I call it the magic number because I'm a nerd, I guess. So the process for finding that magic number is going to work like this. You're going to take the b value, which is the number in front of x, divide that by 2, and then square the result. Okay, that was the process for finding that magic number. So let's see, our b value is 10, so 10 divided by 2 squared becomes 5 squared. And it's important that it's in parentheses, especially if that value is negative. So that missing number for the blank becomes 25. So I add 25 right here, and then I don't add 25 right there. And here's the second big twist for these problems. If you think about what we didn't really add just a 25 to this side. We really added whatever 25 times 25 is if I were to redistribute this. And so on the other side of the equation, you have to be sure you take the GCF into account. It happens to be the same number this time, which is a little confusing, but make sure you take the GCF into account when you go to add both of these values, or add this value to the other side. Okay, that's really the only real thing that's new for these kind of problems. So let's do the same then with the y value. So once again, it's taking half of the b value, which is negative 4 this time. I'll write up here this time. So half of negative 4 squared. So half of negative 4 is negative 2. I said those parentheses are really important for this case. Negative 2 times itself is positive 4. The magic number that you add in the parentheses will always be a positive value. So I'll add 4 right here, and then remember we don't add 4 here, not just 4. Really, I added 9 times 4 on this side of the equation. So let's make sure that 9 times 4 ends up on the other side. Remember, that was our GCF that we took out. So from here, we're really close to getting our standard form equation done, which then means we can graph it and all that stuff. So the whole point of that magic number is it allows you to factor this trinomial. Two numbers that multiply to 25 but add up to 10 would be 5 and 5. And it's no coincidence that it was the same thing. So x plus 5 times x plus 5, or just x plus 5 squared. That's what it means to complete the square, and it's looking more and more like the standard form equation that we're used to. Do the same with the blue part, the y part. So 9, and then two numbers that multiply to 4 add up to negative 4. That would be negative 2 and negative 2. So y minus 2 squared. And then finally on the other side, I'm going to use a calculator and get all that stuff added together. Negative 436 plus 25 times 25 plus 9 times 4 all results in an answer of 225. Okay, our very last step then to get this in standard form, since we like our since we need that number to be a 1 in our standard form equation, your last step will be just divide by whatever's there to make sure that that last number works out to be a 1. So let's go through and divide all our terms by 225. And so I want to go through and simplify a few fractions, and if we simplify the fraction 25 over 225, I end up with just 1 over 9. So typically you'll get a 1 on top, at least if the problem is nice, you'll get a 1 on top. So I end up with just x plus 5 squared over 9. If I simplify the fraction 9 over 225, that ends up being 1 over 25. So that parentheses would be y, or that fraction, I guess, y minus 2 squared over 25 equal to 1. And so voila, after all that work, there's my standard form equation, which means we can now go ahead and graph this and find the vertices and all that stuff. So I've already done that step, so I'll show you my result. But if you need some help, let's just flip there right now. If you need some help finding how I got some of these values, how I got this graph, my last few videos, if you scroll back in the playlist a little bit, you should see how I did a similar problem to find the center, find the foci, find the vertices, covertices, and all that. Otherwise, I'll leave this screen up here for a minute if you want to, or no, I don't, just pause the video if you want to see it. So pause the video if you need some details on getting this graphed and analyzed.